Hello everyone, welcome back to my channel. So today we are going to learn about a very interesting concept in data structures, which is the StackDeque. So we'll be covering the following topics: what is a stack, what is a deck, what is StackDeque, how StackDeque works, and finally the code implementation. So by the end of this lesson, you will be able to explain how stack works, how deck works, why we need two stacks to build a deck, which is also known as StackDeque, and how the program executes step by step. So let's begin. Okay, so what is a stack? A stack is a linear data structure that follows the rule LIFO, last in first out. A very easy real-life example of a stack is a stack of plates. Imagine you're placing plates on one on top of another. So the last plate you placed is the first plate you remove. So in stack, there are two basic operations. To insert, we use push. To remove, we use pop. We can only access the top element. So stacks are also used in undo or redo in Microsoft Word, browser back button, function calls in programming languages. So basically stacks are used everywhere. So moving on, let's talk about deck. So deck stands for double-ended queue. Double-ended queues can perform delete and insert from both ends, front and rear. In a normal queue, we insert from back and remove from front. But in a deck, we can insert at front, insert at rear, delete from front, delete from rear. So basically it is very flexible. So let me explain this like students standing in line. Imagine there is a line of students, but this is a special line. A student can join from the front or from the end. A student can leave from the front or from the end. So this is exactly how a deck works. So moving on to our main topic in our algorithm series, what is StackDeque? StackDeque means implementing a deck using two stacks. In our implementation, we will use one stack for front side elements, one stack for rear side elements. We call them front stack and rear stack. So why is two stacks? This is because a stack naturally reverses the order of elements. So by transferring elements from one stack to another, we control the sequence in which elements appear. Okay, so now let's see how StackDeque works. So basically this is how we implement a deck using two stacks. So stack 1, we should have a front stack and a back stack. And now the basic idea is the top element should come to the front side of the deck, and the top element in the back stack should come to the back side of the deck. So we'll see an example to understand it more clearly. So as you can see, there are some operations that we can use. As I said before, there are 4 operations: push back, push front, pop front, and pop back. So by using all these 4 elements, let's implement a deck using 2 stacks. So in the first operation, they say to push back 8. So now we need to check if the 2 stacks are empty. So since it's empty, we can use these operations. So they say to push back 8. That means you need to push 8 but in the back stack. So this is the back stack. So we need to push 8. And then they push 8 and now push front 7. So push front 7 means you need to push 7 but from the front stack. So front stack is here. You push 7 and 8 remains in the back stack. And then push back 3. So push back 3 means you need to push 3 but in the back stack. Then pop front. So pop front means you need to check the front stack and you need to pop it to the back stack. So that is what pop front means. So 7 goes to the back stack. That means 7 comes here, 3, 8 stays in the back stack. So now front stack is empty. Next they say to push front 5. So 5 comes here in the front stack and 7, 3, 8 stays in the back stack. Then push front 2. So 2 is the top element now in the front stack and 7, 3, 8 stays in the back stack. And once again they tell now to pop back. So pop back means you need to pop the first top element, which is 7, to the front stack. So 7 comes here, 2, 5 remains in the front stack, and now 3, 8 are in the back stack. And again they tell to pop back. So that means 3 should come to the front stack. So 3, 7, 2, 5 are in the front stack and 8 is in the back stack. So to implement a deck using 2 stacks, we need to check the top element is 3. So 3 comes to the front side of the deck. And then 7, 2, 5, we need to write it. And then 8 means the top element in the back stack. So 8 comes to the back stack or rear stack. So this is how we implement a deck using 2 stacks. So lastly, I will be explaining the code for StackDeque. So I will be doing this using Java, but you can use any language you want. So first, we are going to import Java built-in stack class to use it for storing elements in last in first out manner. So we know that we are going to use 2 stacks to simulate a deck. That's why we import the built-in stack class here. So next you can see public class deck using stack. So this declares a public class named deck using stack. Everything related to the deck implementation will be inside this class. So next we have declared 2 stacks, front stack and rear stack. So front stack means for operations at the front of the deck. Rear stack means for operations at the rear of the deck. Using 2 stacks allows us to simulate insertion and deletion at both ends efficiently. So next we have implemented a constructor. So this is a constructor. It runs when you create a new deck using stack object. So it initializes both stacks as empty. Insert front int x means it is a method to add an element at the front of the deck. Front stack dot push x, it means it pushes x onto the front stack. That means top of the stack is the front of the deck. For example, if deck is empty, we do insert front 10. So then front stack equals 10, like that. Then insert rear int x means method to add an element at the rear of the deck. Rear stack dot push x means pushes x onto the rear stack. That means top of the stack is the rear of the deck. Example is like if deck is empty, we do insert rear 20, then the rear stack will be 20. So here we have use the delete front. So this means it removes the element from the front of the deck. So first we need to check if the front stack is empty. So if it is empty, we need to move all the elements from rear stack to front stack. So we can remove the front element. This is done using front stack.push rear stack.pop. Pop elements from rear stack and pushes to front stack, reversing the order, LIFO. So if front stack is still empty after this, the deck is empty. Otherwise, front stack.pop removes and returns the top element. So that is, this is the front of the deck. Next, delete rear. So delete rear means removes the element from the rear of the deck. So it works symmetrically to delete front. If rear stack is empty, move all elements from front stack to rear stack. If rear stack is still empty, that means the deck is empty. Otherwise, rear stack.pop, which is here, removes and returns the rear element. So to display, we use this display function, and that means it prints all elements in the deck in correct order. So we create a temporary stack temp to reverse front stack. This is used because the top front stack is front of deck. That's why we use a temporary stack. So loop through front stack from top to bottom and pushes element to temp. Pop from temp and print. This gives front elements in correct order. Then iterate rear stack and print elements directly. So that is, the rear stack is already in correct order. And finally, we will be going to our main method. So this is used to test the part of our code. So in our main method, we are going to create an object called DQ. So deck using stacks is the constructor which initializes two empty stacks, one for the front and one for the rear. So at this point, front stack is empty and also the rear stack is empty. So DQ insert front 10 means we insert 10 at the front of the deck. So this pushes 10 onto the front stack. So now we know that the front stack is 10 but the rear stack is empty. Next is we insert 20 at the front. So that means we push 20 on top of the front stack. So now the front stack, on top of it, we have 20 and then 10, and rear stack it's still empty. So basically the deck will look like 20, 10. And next is DQ insert rear 30. So here we insert 30 at the rear. So this pushes 30 onto the rear stack. So now the front stack will have 20, 10 and the rear stack will have 30. So conceptually the deck will look like from the front stack 20, 10 and then 30, because 30 is pushed from the rear side. Next, DQ insert 40 means we insert 40 at the rear. So this pushes 40 on top of the rear stack. So now the front stack will be 20, 10 and the rear stack will be 40, 30 and 40 will be on top. So the deck will look like 20, 10, 30, 40. DQ display means the output. So the deck will be 20, 10, 30, 40. So this prints the current state of the deck. So that's why we have put DQ display. So the method temporarily revises front stack to show elements from top to bottom, and it prints elements of rear stack in order. So that's why the output will show 20, 10, 30, 40. So this line means we delete an element from the front. The delete front method pops the top of the front stack. So the front stack is 20. So the output will print as deleted front 20. So now the front stack will have 10 because we delete 20, and the rear stack will have 40, 30. Next, we delete an element from the rear. The delete rear method pops the top of rear stack, which is 40. This will output and print as deleted rear 40. Now the front stack will be 10, rear stack will be 30, because earlier we deleted the front stack 20, and also now we deleted the rear, which is 40. So now the deck will be 10, 30. DQ display means it prints the current state of the deck after deletions. So if we run this, we should get 1030 because we already deleted the front and front 20 and delete rear 40. So let's run and see. Okay. Based on the operations in our main method, the final output of the program will be like this. Deck 20, 10, 30, 40, deleted front 20, as I said before, deleted rear 40. So I said that the final output will look like 1030, and yes, the final output is printed as deck 1030. So that means our implementation has successfully created a deck using two stacks, by using one stack for the front and another for the rear. We were also able to perform insertion deletion from both ends efficiently. So this is a simple StackDeque implementation using Java.